You know, when you look at the ground, it seems pretty solid, doesn't it? I mean, it's permanent. A rock is, well, it's just a rock. But what if I told you that the ground we're standing on right now is actually part of this huge, super slow-motion story of constant, and I mean radical change?
I mean, seriously, think about it. Have you ever seen a rock change, like with your own eyes? You could probably stare at one for your entire life and see, well, nothing. But here's the thing, they are changing all the time, all over the planet. And that is the big mystery we're going to crack open today. So, let's put on our detective hats for this one. The rocks, there are clues. And trust me, when you put them all together, they tell this absolutely incredible story about the history and even the future of our entire planet. It's time to start looking for some evidence.
All right, so our first stop isn't even on the surface. Nope. To really get what's happening up here with us, we have to go way, way down, deep inside the Earth. We're basically taking a journey to find the massive engine that's driving all this change.
Okay, so the Earth is basically built in three main layers. We're living on the crust, which is actually a super thin outer shell when you think about it. Right below us is the mantle, this huge, thick layer of hot, gooey, semi-solid rock. And then, at the very center, you've got the core. And get this, it's as hot as the surface of the sun. Insane, right?
If that's a little hard to picture, here are a couple of easy ways to think about it. You can imagine the Earth like a giant egg. The shell is the crust, the egg white is the mantle, and the yolk is the core. Or, hey, think of a peach. The skin is the crust, that fleshy part you eat is the mantle, and the hard stone in the middle is the core. Simple as that. Okay, so this is the key. That middle layer, the mantle, it's not totally solid. It's actually moving. There's this quote that really nails it. Convection currents in this part of the mantle cause plates to move. So these currents, this movement, are the powerful forces that are literally shifting the massive tectonic plates we're all living on.
The best way to imagine this is to think about a pot of boiling water on a stove, right? The heat at the bottom warms the water, it gets less dense, and it rises up. Once it hits the cooler surface, it cools down, gets denser, and sinks back to the bottom. Well, the exact same thing is happening inside the Earth, but instead of water, it's molten rock, and it's happening over millions and millions of years. This crazy slow-motion churning is what physically moves entire continents around.
All right, so now we get the engine driving everything. Let's head back up to the surface and meet the stars of our show, our three main suspects, or as geologists like to call them, the three rock families.
First up, we've got igneous rock. And its name is a dead giveaway. It comes from the Latin word ignis, which means fire. And that's exactly what it is. This rock is literally born from fire. It's what you get when magma or lava from deep inside the Earth cools down and gets hard. You've definitely seen it. Think about granite countertops or that cool, sharp, black volcanic glass called obsidian.
Next on our list is sedimentary rock. I like to think of this one as the historian of the rock world. See, it's made when tiny little pieces of other rocks, sediments, like sand or shells, get washed away by water or wind. They settle down in layers, and over millions of years, they get squeezed together and cemented. And here's the coolest part. Because of how they're formed, this is the only type of rock where you can find fossils.
And our final suspect is metamorphic rock. Again, the name tells you everything you need to know. Meta means change, and morph means form. So this is a changed form rock. These are basically recycled rocks. You take an existing rock, like an igneous or a sedimentary one, you bury it deep underground, bake it with incredible heat, and crush it with insane pressure, and it becomes something completely new. A great example is limestone, which gets transformed into beautiful marble. So there you have it, our three main suspects, the fiery igneous, the layered sedimentary, and the transformed metamorphic. But here comes the big plot twist in our detective story. It turns out they're not three separate characters at all. They're all connected. They're all part of the same never-ending story. This is the big reveal. Any rock can become any other type of rock. It's mind-blowing when you think about it. An igneous rock can get worn down by rain and wind into tiny pieces, or sediment. That sediment then gets pressed together to become a sedimentary rock. Then, that sedimentary rock can get pushed way down, cooked and squeezed, and boom, it's a metamorphic rock. And get this, that metamorphic rock can get so hot that it melts back into magma, and the whole thing starts all over again when it cools into a new igneous rock. It literally never stops.
So really, every rock is just on a different part of its journey. Look at how this works. You start with an igneous rock. Weathering breaks it down into sediment. That sediment gets compacted into a sedimentary rock. You add a ton of heat and pressure and it turns into a metamorphic rock. If that rock melts, it turns back into magma. And when that magma cools, you're right back to an igneous rock. It is a perfect, continuous loop.
Okay, so this whole rock detective story is pretty cool, right? But you might be wondering, why does any of this ancient stuff matter to me right now? Well, it turns out this isn't just a geology lesson. It's literally the foundation of, well, everything.
Think about it. That same weathering process that grinds down entire mountains, that's what creates the soil we need to grow our food. And those incredible pressures that forge new rocks, they also concentrate all sorts of valuable minerals that we use for everything. I mean, even the graphite in the pencil you might be using. This isn't just some abstract story about rocks. It's the hidden engine powering our entire civilization.
And that brings us to one final really crucial thought. This whole rock cycle plays out over millions, even billions of years, a timescale that's almost impossible for us to wrap our heads around. But our impact on the planet, all of our mining, building, and reshaping the land, that happens in the blink of a geological eye. So the real question we have to ask ourselves is this: how are we going to write the next chapter in this ancient, powerful, and still unfolding story?